Bismillah ar-Rahman ar-Rahim. Last class we started Unit 6 titled Modeling ROMs, Sequential Circuits, and Finite State Machine using Verilog HDL. Mainly Unit 6 will be covering three sections. Modeling of ROMs, which we already covered. Modeling of sequential circuits. We're going to start this part today. Probably we're going to cover flip-flops. We will also be talking about registers, shift registers, and counters. Most of these we got introduced to in Unit 2, I believe. And then lastly, we'll be covering modeling of finite state machines. Okay, so just a quick review about ROMs. A ROM acts like a memory, have a number of inputs. These inputs will be the address to a certain location in your ROM, and then the outputs correspond to the data bits that each location in your ROM will be storing. Okay, so for example, in this ROM, I have 3-bit for the address. That means this ROM will have 8 words because that's going to be 2 to the 3. And then the data output size is 4-bit. بالتالي I can implement 4 functions in this ROM. Okay, how to declare them in Verilog? There are 3 parts for declaring memory. So the first part, we're going to define the input, which is the address. This is the address bits. We have a vector of 2 inputs, x and y, 2-bit each. That means this is a 4-bit address, meaning we have 16 words in this memory. And how many bits for each word? This is going to be defined by the output. So the output is 2 to 0, that's 3-bit. So this is a 16 words by 3-bit per word memory, أو ROM. And then we need to declare wires for the memory block. This is where we're going to store the information in this ROM. Okay, so we're gonna define an array of vectors. So it's a 16-element array. Each element is 3 bits. This has to match the size of your output, and this has to match 2 to the n, where n is the number of bits of your inputs. Okay, that's the first part. Second part is to fill the memory locations with the data that you need, depending on your function, of course. So we're going to have, since this is a 16-word memory, we're going to have 16 assigned statement, one for each address. And what you'll be storing is 3-bit. This 3-bit has to match your output. Okay, that's the second part. Third part and last part is to assign an output to this ROM. Okay, so what we do is we read the structure that we created from wires and we pass the address according to the input. Now that's all about ROMs. So in this section we'll start modeling synchronous sequential logic. Now we covered so far, or what we covered so far in this course, was modeling of combinational circuits, and we saw many ways to do that. We can use either continuous assignment statements, either using assign or structural modeling, and we can use procedural assignment. Procedural assignment is the one that inside the always block. For procedural assignment, you can use if والwhile والloops, all these high level syntax. بالنسبة للsequential circuits in Verilog, you can only model that using procedural statements. Okay, you cannot use continuous assignment statement for sequential circuits. السبب إنه sequential circuits are always changing. It's not like combinational circuits. ف we will have we're gonna be using the always block for that, since procedural assignment has to use the always block. Any procedural statement has to be inside an always block, and we already know that from Unit 4 and Unit 5. Okay, so um, I think here it's just repeating what an always block is. We have the always and we have the sensitivity list. بالنسبة للcombination circuit, our sensitivity list was a list of all the inputs in your circuits. Whenever one input change, we have to access the always block and execute all the statements that we have in here. In sequential circuit, no. We know from sequential circuits that we only evaluate any logic at certain times regarding in respect to the clock. فمثلا عندنا في الفليب flop, you only model أو you only check the logic of your circuit at certain times. بالنسبة للفليب flops, this is either gonna be the positive edge of the clock or the negative edge of the clock. هذا بالنسبة للفليب flop. بالنسبة للlatches, we check our logic at a certain level, يا إما positive level of the clock or the negative level of the clock. Okay, so this is gonna affect our sensitivity list, and we will see how. Now for latches, it's gonna be very similar to what we did before. Just a quick review about the D latch, or we can name it the gated D latch. Gated D latch إنه we will access it at a certain time. So the gated D latch أو ما يسمى بالtransparent latch. إيش يعني transparent؟ Transparent يعني شفاف. At a certain time أو at a certain level of an input signal, we call it G. هذا اللي كنا نسميها clock. If G is equal to 1, Q will take the value of D. If G is equal to 0, Q will save its previous value. So if you check the truth table of that, I have three inputs. I have G, I have D, and I have the value, the current value of Q. And I need to find out the value of Q plus اللي هي the next state. So if you fill the truth table, notice that if G is equal to 0, Q plus should equal to Q. Okay, 0, 0, 1, 1, 0, 0, 1, 1, regardless of the value of D. Now, if G is equal to 1, the next state should equal to your new input coming from D. Okay, so these two are going to be the same in case G is equal to 1, and these two has to be the same when G is equal to 0. Make came up for the next state Q plus, and then you'll find that Q plus will equal to G bar Q or GD. Now we can easily model that using an always block as follows. Module D latch, we have two inputs, G and D, and one output rig, which is Q. طبعا output rig Q can be used in this case. We'll just model it. Okay, we'll just model it in a simple procedural statement. So always at G or D, we're gonna access the always block, and if G is equal to 1, change the value of Q to whatever you have in D. Otherwise, do nothing. So if you do nothing, that means Q will stay the same. طبعا always remember, any value that you change or you use in the left hand of an assignment statement inside an always block has to be declared as a rig. Okay. طيب, so Now the D latch behaves as follow. We have the D latch will be transparent. That means Q is equal to D. This is when the gate is high or the clock is high, or it's going to be opaque. Opaque يعني كترجمة يعني معتم, meaning that Q will not see the value of D or will not be affected by the value of D. So it will be retaining its old value. It will save whatever value it had before, regardless of any changes of D. Okay, it's like saying that Q is equal to Q. Now, in sequential circuits, if you remember from CN211, we used to use flip-flops for design of sequential circuits. طبعا الفليب-flop is a group of two latches together with inverted clocks. So if I have a D latch in here, just connect them this way. For the clock signal, one of them will take the clock, the other will take the inverted clock, and this will give us a flip-flop. تمام. ولكن اللاتش can be used at its own for designing sequential circuits, ولكن it's more complicated to use. يعني you need to be careful when using latches, and it's applicable for certain designs. تمام. So for us, for any sequential circuit, we usually use flip-flops, just like we did for counters and for shift registers in this course. We used flip-flops. طبعا الفليب فلوب في انواع. عندنا الدي فليب فلوب, we have the T flip flops, which also we used in some counters that we saw in unit 2. We have JK flip flops and the SR flip flop. I think these are the only ones that we used before. Yeah, D, T, and JK and SR. Okay, but how to create a latch? That's how to create a latch in Verilog. Let's review the edge triggered D flip flops. So an edge triggered D flip flop is I don't like it this way, so let's do it here. D, Q, and Q bar. So you have an input D, an input for the clock, and then we have two outputs for Q and Q bar. Now, if the symbol is written this way, that means this is a positive edge triggered flip flops, meaning the value of Q will take the value of D only at a positive edge of the clock. So at this certain time, when the clock is moving from 0 to 1, that's called the positive edge, we're going to read the value of D and write it to the value of Q. If the symbol of the flip-flop is have a small bubble at the clock input, that means this is a negative edge triggered flip-flop, meaning at each negative edge, check the value of D, write it to the value of Q. For example, check this timing diagram. This is a timing diagram for a D flip-flop. Now that's not enough information. If I have a D flip-flop, I need to know, is it a positive edge or a negative edge? So this is a falling edge trigger, meaning this is a negative edge triggered flip-flop. Okay. معناه at each negative edge, I will sample the value of D and equate it to Q. Okay. So if Q started at 0, up until this edge is going to stay the same. When I reach the negative edge, now read the value of D. For negative edge, let's read the value of D. D is equal to 1, so make Q equal to 1. Now if Q equal to 1 here, it's going to stay the same until the next negative edge. Read the value of D. D equal to 0, معناته Q will fall to 0. Any changes in D will be ignored between these two negative edges. Okay, so for Q, I don't care what's happening in D. I will only check D at the negative edge. Now, Here d is equal to 1, so q will be 1, and it will ignore any changes until the next negative edge. Check the value of d, it's 1, so stay at 1. Next negative edge, d is equal to 0, I will go to 0. And I will stay until the next negative edge, d is equal to 0, so stay at 0. Notice that d here went to 1, from 0 to 1, and then back to 0 again. This change did not reflect on q because it's happening in between the two edges, so it will be ignored. So again, a flip-flop will sample data only at a certain edge, either a rising edge or a falling edge. We call this a positive edge triggered flip-flop, and this is a negative edge triggered flip-flop. Okay, so how do we define that or tell Verilog that we want to follow this behavior? We're going to use an always statement, but instead of having all the inputs listed in our sensitivity list will change. We will write a certain code. I want to access this code only when you have a positive edge of a certain signal, which is for us, it's going to be the clock. So when you write always at pause edge clock, that means when clock goes from 0 to 1, enter this always block and execute whatever you have in there. If you write always at neg, which is short for negative edge of the signal clock, go inside and execute whatever statements we have. So the changes between the main difference between combinational and logic circuit in using the always block, the sensitivity list of a sequential circuit has to follow either a positive edge or negative edge.
دكتور،
تفضل.
صح لو ما حددنا بيصير يقراها على كل بوزيتيف ايدج والنيجاتيف.
اذا ما حددت نهائيا معناه always block will be entered at any change of your circuit.
اي سواء
It's
نيجاتيف
like
او بوزيتيف.
سواء negative او positive او حتى changes in the inputs. يعني حتى لو
اها،
مثلا الفاليو اوف دي تغيرت برضه حيدخل always block, which is incorrect.
وصح
انت
لازم انه يعني في الاولويز انه نخليها على شيء واحد. يعني الحين ما دام خلينا بوزيتيف بوزيتيف ايدج حقت الكلوك، ما نقدر نحط شيء ثاني وما هو بوزيتيف ايدج.
لا تقدر. You can.
يطلع لنا ايرور ترى،
لا
جربناها
لا
في
لا
اللاب كان عندنا ايرور.
لا ما يطلع ايرور. يطلع ايرور اذا استخدمت مثلا positive edge of clock وكتبت مثلا x. اوكي.
اي
اي هذه تطلع ايرور. But you can have more than a signal to get inside the always block, بشرط انه السيجنال الثانيه has to follow either a positive edge or a negative edge.
احددها برضو. اي
اي لازم يكون as long as you used one with positive or negative edge, any other signal has to have also positive or negative edge identifier. هذه ايرور صحيح، هذه ما تنفع. لكن اذا حطيت
اي
مثلا
لان
هنا
المرتين ما
اي اذا
حددنا لا
حطيت هنا
بوزيتيف ولا
positive
نيجاتيف.
edge of x, this will work. Um, just few slides from here we will talk about adding these signals. سؤالك اللي قبل positive and negative edge of clock, you're talking about a double edge triggered flip-flop. You know, this flip-flop will sample data at the rising and at the falling edge. So in the always statement, you can write always. If you want a double edge triggered flip-flop, you can write always at positive edge of clock or negative edge of clock. Now this will create a double edge triggered flip flop. ولكن ال double edge triggered flip flop we did not cover أو يعني how to design circuits to work on double edge triggered flip flop. But this is how you do it. If you write that كده حيتغير مع البوزيتيف ايدج والنيجاتيف ايدج. ولكن always at anything هذه غير، هذه حتتغير also with each input. اذا كان عندك two input مثلا x and y حيتغير معها، فغالبا بتصير هذه combination circuit not a sequential circuit.
ايوه وضحت.
Okay, so let's check the code for D flip-flops. We're going to create a module called D flip-flop. We have input clock, we have input D, and we have an output rig Q. Remember that output has been declared as rig because the value of Q will be changed inside an always block. So we write always at the positive edge of the signal clock. That means when clock transfers from 0 to 1, access this block. Then we can simply write Q takes on the value of D. Now, do you remember this? كان عندنا فرق بين Q equal D and Q takes on the value of D. This is a blocking assignment and this is a
نون بلوكينج.
non-blocking assignment. Okay, a non-blocking assignment will update the value of Q after you finish executing the whole procedural statements that you have inside your always block. بالنسبة للblocking, it will update the value of Q even if you still have uh, more assignments after this one. فمثلا إذا كان عندك A equal to B and then C equal to A, these are blocking assignments. So C will see the updated value of A. Well, and this was in your homework. So, but if you use A takes on the value of B and C takes on the value of A, now this value of A will be whatever A was before executing this always block. تمام. So the value of التشينج اللي حيصير على A هنا it will not be reflected in this value. That's why it's called non-blocking. طيب هذا بالنسبة لل D flip flop. One other type of flip flops that we're going to talk about اللي هو ال T flip flop. بالنسبة لل T flip flop, if T is equal to 0, the value of Q plus should equal to Q. معناته hold the value of Q. And if T equal to 1, make the next value of Q equal to Q bar. Okay, so in general, Q plus will equal to T bar Q or T Q bar. If T equals 0, Q plus equal to Q. If T equal 1, Q plus will equal to Q bar. And this is from Boolean algebra. This is T XOR
XOR.
Q. Okay, so you can use a D flip flop for that. If you have a D flip flop, what you can do is take Q, take T, XOR them together, and apply it to the input D. And this is clock. Now, this whole thing is a T flip flop and can be written as T, Q, Q bar, and clock. Now, the symbol here has a small bubble at clock. That means this will this will only read at the negative edge of the clock. So let's check the code very quick. We have module T flip-flop. I have three signals, clock, T, and Q. if I have, I'll declare input T and clock, and I have one output trig Q. So always at the positive edge of the clock. So this is not this circuit. It's going to be the same ولكن without the bubble. Okay. طيب, so always at the positive edge of clock, Q will takes on the value of T XOR Q. Okay, that's it. Now let's check the timing diagram. Assume that Q starts at the value of 0, and we are reading. I'm assuming this timing diagram is following this code and not following this symbol here. So let's assume that this is
دكتور
positive edge. Hey.
ليه خلاها نون بلوكينج؟ ما هي المفروض بلوكينج على أساس كل ما تغيرت القيمة تتغير.
لا شوف في السيكونشال سيركت اساسا الكونسبت اوف بلوكينج should not be used at all, لانه الفاليو that you read should be all the old values that are present at your input. تمام؟ يعني مثلا اذا عندك ترى البلوكينج assignment في السيكونشال circuits makes no sense, and if you use blocking assignment while using positive edge and negative edge, you will see that the logic is not what you thought of. So افترض عندك two flip flops. تمام؟ you have input D here والاوتبut is going to the next input. okay. طيب افترض ال previous value I was storing 0 here and I'm storing 0 here and D is equal to 1. okay. الآن when the positive edge come, what are the new value of these two flip flops? What do you think?
شو اسمه الثاني بياخذ القيمة القديمة حقت الدي، والأول بياخذ القيمة الجديدة حقت الدي.
طيب يعني after this positive edge this should turn into 1 and this should stay at 0. صحيح؟
ايه
طيب إذا استخدمت blocking assignment هنا كتبت إنه Q equal to D وهنا كتبت Q equal to مثلا هذا نسميه خلينا نعطيه أسماء، نسمي هذا A وهذا B. تمام؟ وكتبت Q is equal to A. إيش حيصير عندك؟ if you use
وتصير
blocking
كلهم
assignment
واحد.
أي حتصير كلهم واحد. تمام؟ ف this is against the logic of sequential circuits. في الفيريلوج تقدر تكتب inside ال always block اذا استخدمت، حتى لو استخدمت at positive edge of clock وداخل ال always block استخدمت blocking assignments it's gonna work، يعني it's gonna synthesize، ولكن the circuit that it's gonna synthesize is different than what you think. We're gonna see an example of that يعني few slides from here if we reach it today. تمام؟ ف in any sequential circuit you should use a non-blocking assignment. Okay, and we're going to see the difference if you use a blocking assignment, how the circuit will look like. طيب, let's go back quick to the T flip-flop. If this is a positive edge triggered flip-flop, I will a positive edge triggered T flip-flop, I will only sample the data at, or I will only change Q at the positive edge of the clock. At this edge, come here, value of Q equal to 0, T is equal to 0. If T equal to 0 means hold, so keep the value of Q at 0. تعال to the next positive edge. Now T is equal to 1. T equal to 1 معناته complement the value of Q. So if Q is 0, go to 1. Now stay at 1, ignore any changes in T up until the next positive edge. T equal to 0 meaning hold, so no change up until the next positive edge. Now T is equal to 1, go ahead and complement Q. Next positive edge, T is equal to 1, complement up until here. T is equal to 0, meaning hold. Okay, so this timing diagram is showing a positive edge triggered T flip-flop. Okay, which is following exactly this module. That's just the same as implementing the T flip-flop. And T flip-flop is going to use a D flip-flop with an XOR at the input. This is what we did in this slide. So this is the same as this one. Now, since you can implement a D flip-flop and um, a T flip-flop, we know that there are some extra signals that we can use in flip-flops اللي هي usually the reset, the enable and اللي يسموه set أو يسمى أحيانا preset. Okay. So these are usually used to initiate your circuit. You have to either set or reset your flip-flop to a certain value depending on your circuit. And we saw examples of that when we talked about counters. One of the counters, you have to set your initial state to 0001. So not all flip-flops have the reset signal. You need a set and a reset signal. I think we also talked about the difference between synchronous and asynchronous reset. So if you're talking about reset, now imagine you have a D flip-flop with an asynchronous reset. أحيانا reset يسمى clear ولكن we usually go by reset. An asynchronous reset معناه if this signal is active, make the value of Q equal to 0 anytime بغض النظر عن الكلوك. Asynchronous معناه غير متزامن with the clock. Synchronous معناه متزامن with the clock. Now if you're using a synchronous reset معناه انه if reset is active, it needs to wait for either the positive edge or the negative edge of the clock depending on your flip-flop to apply that reset. Okay, now this is very important to understand. عندنا synchronous وعندنا asynchronous. Synchronous متزامن مع الكلوك. Asynchronous غير متزامن مع الكلوك. Now هنا if reset خلينا نقول reset is active high فمعناته if reset equal to 1 let the value of Q equal 0. افترض انه هذه الكلوك this is the value of Q تمام و Q it's changing at the positive edge صحيح always Q is changing depending on D ما يحتاج ارسم السيجنال of D I'll just assume that it's going this way. okay معناها D كانت هنا 1 D here is 1 and D here is 0. So this is a D flip-flop. A positive edge trigger D flip-flop. Now, if I add a reset signal to my flip-flop design, if this reset is synchronous, so هذه الvalue of Q is without reset. تمام؟ The design of this flip-flop does not have a reset. الآن افترض عندي reset signal والreset signal هذه goes to 1 here. Okay? Now, let's see Q if this was a synchronous reset and if this was an asynchronous reset. If you're using a synchronous reset, Q will just follow خلينا نقول Q will follow this value تمام. الآن when you reach this edge عندك D equal to 1 ولكن reset is also 1. ف when reset went to 1 here it will not gonna reset right away. لا it will wait for the positive edge of the clock. الآن صار عندك reset equal to 1 و D equal to 0. which one you're gonna take, the D or reset? You should first take the reset. If reset equal to 1 خلاص عندي high priority for reset. That means if reset equal to 1 جاني البوزيتيف edge, I'll just pull my Q to 0. Asynchronous reset, لا, we're gonna go 1 here because D is equal to 1 clock positive edge وعندي reset equal to 0. Now when you come here for asynchronous reset معناه I need Q to change بغض النظر عن clock. So in this case Q will pull down to 0 whenever reset went to 1. Asynchronous غير متزامن مع clock. I don't care where are we in this cycle. If I put my reset 1, Q, you go to 0. Okay, فهذا synchronous reset وهذا asynchronous reset. It's important to understand the difference between these two. That's one thing. Secondly, بالنسبة للreset والset, usually these signals are active low. معناه if reset equal to 1, the circuit should behave normally, just like any D flip-flop without the reset signal. If reset equal to 0, لا, this time أعطيني Q equal to 0. سواء كان synchronous أو asynchronous. And as a convention in Verilog, usually we write, if you write a name of the signal and then follow it with the letter N, that means this is an active low signal. هذه as a convention يعني, it's not required ولكن as a convention. Just to make it easy when you read someone else's code, that you know if this signal is active high or active low. So when reset N equal to 0, the flip-flop output Q will be set to 0. Okay. طيب.
واضح.
هذه this part is what we talked about last slide اللي كان سؤالك يا عبد العزيز. The sensitivity list contains either all edge sensitive أو all level sensitive. هذه level sensitive. And if you write positive edge أو negative edge, هذه اللي هي edge sensitive. Okay. your sensitivity list either contains all level sensitive أو all edge sensitive. You cannot mix both. طيب انا عندي الريست سيجنال انه what I need يعني I need اني I execute my code when I have a positive edge of clock and at the same time if I have a change in reset. هذه في حالة I want to make an asynchronous reset. تمام؟ لأنه asynchronous reset I don't want to follow the clock. If you just simply write an if statement inside your block modeling the reset, this is a synchronous reset. ليه؟ لأنه you're not going to enter the code unless you are following the clock. ولكن إذا كتبتها بهذا الشكل لا. معناته I can execute the block either at the positive edge clock أو we have a change at reset. Now Verilog will not allow that. انك انت تكتب edge sensitive signal وعندك واحده level sensitive signal. فwhat you can do انك you change this reset to an edge sensitive signal. How can we do that? انت متى تبغى تدخل بلوك او متى you want to reset at positive edge مو معلش at reset equal 1 ولا reset equal 0. you want to clear when reset او خلينا نسميها
equal
reset
0.
n. ايوه نسميها reset n just to follow the convention. If reset n equal to 0, I want to reset the clock. So change this from reset to negative edge of reset. تمام. So you will enter this block whenever your reset signal goes from 1 to 0. From 1 to 0 enter this block. داخل البلوك حنشوف كيف نسوي الريست. تمام. ولكن talking about the sensitivity list, I will enter my always block في حالتين. يا اما I have a positive edge of clock او a negative edge of of signal reset n. Okay, we're gonna see the complete code of these flip-flops. طيب هذا شرح لل asynchronous. سواء طبعا الاسynchronous هذا ينطبق على الست والريست. Either you want to set or reset, these both have two variations. يا اما تكون synchronous او تكون asynchronous as we explained before. Now you can also add an enable signal. Enable signal for the whole flip-flop. If enable equal to 1, just behave normally. If enable equal to 0, ignore all the signals that you have. Okay, do I have the enable here? Not really. Uh, this one is for preset and clear, which is يعني أنا عن نفسي I call them set and reset. But you have to understand what's a preset and what's clear. Preset يعني set. Reset وclear يعني reset. Don't confuse preset انها equal to set. لا. preset معناه set to 1. reset او clear معناها set to 0. Okay? Don't get confused in these terminologies. طيب بالنسبة للenable, I think it's going to talk, yeah. So here it's going to talk about enable. So if enable signal is 0 and the active edge of the clock occurs, سواء كانت positive or negative, this flip-flop cannot change the stored value. فإذا عندك clock بهذا الشكل واعتبر إنه هذه positive edge clock, عندي the value of D is changing like this. So this is clock, this is D. Normally your Q should here go to 1, بعد كده here it will go to 0 and it will stay this way. ولكن افترض انه عندي الفليب فلوب هذا with an enable signal وانا حطيت الانيبل to 0. enable equal to 0 معناته ignore all changes in D and in clock. Okay, enable equal 0 معناته this flip flop is disabled. So don't listen to the clock and don't listen to D. If enable equal 1 for the same flip flop, لا, Q will go and behave normally. We'll also see how to model these. فعندك two ways of making a flip flop with enable. First one is using a multiplexer with the value of enable. If enable equal to 1, forward D to this signal, فكده صار كأنه flip flop عادي. Now if enable equal to 0, لا, what you forward here is Q. So this value will be Q. معناته this flip flop will hold the value of Q forever. أو as long as enable is equal to 0. This is one design. Another design is using clock gating. كلمة clock gating إني I go to the clock signal that's coming to my flip-flop and I AND it with an enable signal. So if enable equal to 1, what you're gonna see at the output is your clock signal. That means your flip-flop will work normally. But if enable equal to 0, your output is 0. And if you don't have any changes of edge for a flip-flop, there will be no change in Q. Okay, so we have these two ways to implement the enable, either using a multiplexer or using what is called clock gating. طيب, in these slides, I think we'll have a few, we'll have, let's go over these codes. If you want to make a flip-flop, D flip-flop, with a synchronous reset, a synchronous active low reset, عشان كده سميناها reset N. For your module, we have clock as an input, we have reset N as input, and we have D. And then we have an output Q. Now, الفرق عندك حيكون في الsensitivity list. So my sensitivity list here is at the positive edge of clock. Go inside my code. First, I need you to check the value of reset. If reset N equal to 0, معناته reset is active, and this is an active low signal. Let the value of Q take the value 0. Else, معناته if reset N equal to 1, meaning I don't want to reset, just behave normally. A normal behavior of the flip-flop إنه if you are at the positive edge, let D equate to Q. Okay? Now, why this is a synchronous reset? لأنه I will not check this signal unless I am at positive edge of clock. معناته I'm still following the clock in this case. What if you want to make this an asynchronous reset? معناه I need to access this block also at the negative edge of reset N. So I'll ask this block in two ways, either at the positive edge of clock أو I have a change in signal reset. طبعا ليه اخترنا negative edge لأنه we have an active low reset. تمام. Note that this code is the same here and there. This code is the same. ايش غيرنا؟ غيرنا ال sensitivity list. We went from only following the clock to following the clock and following our asynchronous signal. Okay, inside check. طبعا ال sensitivity list هذه او ال always block will be executed at any one of those. فinside your block you need to check which one accessed your block. فhere I'll check is it reset? Okay, then make q equal to 0. If it's not reset, معناته I accessed this block at the positive edge of the clock, so give me q takes on the value of d. Okay. Now, this is it the same? This is the same code but with positive أو اللي هو الactive high reset. The only change that you will have here is in the if statement. If reset equal to 1, reset. Second is here. In the previous one, we used negative edge of reset n لأنها active low. هنا you need to use the positive edge of reset. So this is going to be a synchronous reset on an active high reset, and this is going to be an asynchronous on an active high reset signal. Okay, we will stop here, and from next class we will continue on flip-flops. I think we have a few more slides. We already talked about blocking and non-blocking actually, but we need to go through this example to see the difference. What else we have? Yeah, and then we can move on to talk about um, registers, shifters, and registers, shift registers, and counters, inshallah. Okay. Any questions?
ان شاء الله يعطيك العافيه.